Hello everyone, welcome back to this channel. Now it's this channel is about nearly 140 videos created since December last year, 2024. So that's only about not even quite 2 months. So if you haven't subscribed this channel, so it's time now to so. So you can access all those videos, 140 videos in one hit. Just click on the playlist. And subscription is very easy. Just click on the bell to subscribe this channel. Thank you. Okay, today we're going to investigate this question, 2020 VCE Specialist Math Exam Paper 1. It's an interesting question. It's got a parametric equation or function. So we got a two, so xt and yt. So we got two questions. First, we want to do now this is not a double derivative, so make sure you don't misunderstand this question. This here is the first derivative, which is with respect to t, derivative y with respect to t, then the square. So we want to make sure we understand that's a derivative square. All right, so you can see if I want to prove in that form. So once you can see pretty simple, this is like almost like a, so we're going to use this perfect square formula. So a plus b or minus square is a square plus more minus 2ab plus b squared. So this is the formula we're going to use. So if you look at the expanding the brackets, so you got square term and a product and put a 2 in the front. So that's a product. All right, so look like this is a square expanding the perfect square. So let's do that. So if we use y equal to the log, we use ln and copy this question, and derivative y with respect to t is 1 over t, 1 plus t. Actually, I'll put 1 plus t. Just make sure it match up. And minus, because it's negative, so 1 divided by 4 times by bracket t, 1 minus t. So when I do square, so we make sure we're using the perfect square. So I'm going to expanding the first, expanding the square, that's a square. So that's the a square minus 2 times by a times by b and plus b squared. So that's how we're expanding the brackets. So then if you look at tidy up, so we got should be 1 plus t. Just match up with the question. And this should be 1 plus t. Same. T plus 1 plus t, same. 1 plus t. All right. So now because these two together, it's a difference of square. So we know another formula we're going to use is 1 plus a plus b, a minus b, equal to a squared minus b squared. So this is a both way. So this become a squared minus of b squared. So then we tidy up. So the answer will, a is 1, b is -2, c is 16. So question A is pretty simple. Question B is we need arc length. Now we know arc length is basically arc length is, so this is the arc length, we say close to the, so this is a dy and this is a dx. So therefore, this is the hypotenuse, which is square root of dy. So we can put a dx square plus dy square. Then if we want to be a total curve, we just integrate it. So the total curve, the arc length is from 0 to half, because of t is 0 to half, and dx, so the derivative of x with respect to t square plus y dash t square. So that's the formula we're going to use for arc length. All right, so let's do separately. I'm just, because a very big formula, I'm going to do derivative x with respect to t. We got 1 over square root of 1 divided by t squared. So if I square it, so it becomes no square root. So that's the first step. With the derivative y with respect to time, that's the same thing we just did before. Then if I square it, so that's the 3, expanding the perfect square formula, a square minus 2ab plus b square, which I did before. So now we add them together. So put them two together. This 2, can you see I'm highlighting that, and that's become that. So this is a 1, and this is a half, minus half become 1/2. So therefore, 1t square, 1 minus t square equal to 1 minus t, 1 plus t. So that's how we got that. All right, now I'm going to put the first, this into a square term. That's 16 become 4. That's a square term. So this is my a square. So if I'm using, that's a square plus 2. So then this is a, 2a, this is a b plus b square. So the answer will be a plus b square. So that's become perfect square. Now why I need a perfect square? Because it's got a square root here. So we know the square root of integration is very difficult to do that. So we must make sure we can cancel it out. So we need a square, perfect square. So therefore, my arc length, the change to, instead of using square root, now because square root and square canceled out, so become 1 plus t, 1 divided by 1 plus t, and 4 times by 1 divided by 1 minus t. So that's easy. So we're going to integrate it, and then plug in 1 divided by 2, plug in, and we solve the mathematically. So we end up with that. So I'm going to just do one more step, because that's division becomes subtraction, log 3, take away log 2 plus. So I'll put these two together as negative 3 or 4 log 2. So that's my final answer. That's the arc length. Units, we might just say, because we need a length, we didn't know what's units, we just put that's the length of unit. Thank you for watching, and if you like the video, please give us the thumbs up, and I'll see you next video. Thank you. Bye-bye.